So first, let's talk about gradient. Basically, gradient and directional derivatives go hand in hand, and they also go hand in hand with partial derivatives. So let's take our classic example of, let's say, z equals to f of xy here, right? So then we would have x, y, and then our response variable z. And let's say hypothetically, let's say we have a function that creates this plane, right? And basically this plane is created by means of, for every pair of x and y, we have an z value. For every x and y, we have a z value, and then eventually we have all these z values, and they would create this plane, right? So let's remove that, and then we'll continue. So basically, if we have, let's say, x0 here and y0, right? So we would have this point here. This is our xy. Okay, so I'm going to write that down. So then we have x0, y0. This will give us z0, and then this will be, call it here. So this is a point z0 on the plane, right? So this is actually on this plane, this z value here. So then to figure out the rate of change in z, then naturally we would say, we would have change in z with respect to x is just the partial derivative of x and of f of x and y. And this can be evaluated at point x0, y0. And similarly, the rate of change of the rate of change of z with respect to y is f of y xy, and again can be evaluated at this point here, right? So then basically now what we have is we want to know what is, and then again going back here, what is the concept of change in z with respect to x or with respect to y, right? This is basically saying how much will x and y change to produce a small increase in z, right? So basically we can see, for example, let's say for z to go from here to here, to this point, to z1, then, arbitrarily we need a point, let's say we need a point here, right? So then basically our f of x, our partial derivative with respect to x would be saying, okay, for z to increase like that, x has to go this way. And then for z to increase at the same time, y has to go this way, right? So if x goes this way, y goes this way. So if on the xy plane, so that's z. So now let's just focus on just over here. This is the xy plane, right? So on the xy plane, if we're starting here at x0, y0, and then we want to go this way a bit. Sorry, I got to reverse. So this will be x. So then actually we want to go this way in the x direction, and then go this way in the y direction, right? So then you see that's actually the result is actually going from this point 0 to this point here, which is a vector, right? So then now we have basically gone from just simple derivatives to a vector, and we call that vector the gradient. So delta f at x0, y0, this equals to, and this is a vector with x and y, x0, y0, fy, x0, y0, right? So then now let's now look at the concept of this gradient.